Hello friends, we have given a problem of IIT 1999 to check the continuity of a function. The function fx equal to greatest integer function of x square minus greatest integer function of x square. So we have to check that the function is continuous or not at some point. So what is the problem is we have to find out the point where the function is discontinuous. So what we do, first of all, we are going to check that what is the value of the function at integer points. So let consider the function fx equals to greatest integer function of x square minus x square bracket of x square. Again, let m be any integer. So the value of function is, we know that for any integer m square is also an integer. Again, for any integer the value of greatest integer function is the same integer. So this is m square m, and this is also m square. Again, we find out the value of the function at x equals to m. So fm equals to bracket of m square minus bracket under m square, and this becomes m square minus m square, and this is equals to m square minus m square equals to 0. So the value of function at m equals to 0. Again, we are going to check the limit at x equals to m. So first of all, we calculate the left hand limit at x equals to m. So left hand limit at x equals to m. Left hand limit x equals to m. This is the special notation. We know left hand limit is a limit x tends to m minus, and this is bracket x square minus under bracket x square. Again, this can be written as limit h tends to 0 m minus h whole square minus m minus h square under the bracket. So this is, since this is less than m, so value of the bracket m minus h, again we are doing some rough. The rough are, we know that since m minus h is less than m and greater than m minus 1, since h is very near to the left of the m, so value of greater integer function m minus h equals to m minus 1. So m minus h whole square equals to m minus 1 whole square. Again, we have given bracket of m minus h square. So what is m minus h square? M minus h square can be written as m square plus h square minus 2mh and under the bracket, and this value, since h square is near to the m square, and this can be m square minus 2m, and this is also near about the m, so this is the left of the m square. So this can be equals to, this value is the left of the m square, since h square tends to 0. So this is left of the m square. So the greatest m, this value lies between the m minus h square, lies between the m square minus 1 less than m square minus 1 less than uh, m square. So bracket of m minus h square equals to m square minus 1. So we are going to put these values in the given. So what is the value of we have gotten? The value of this is m minus 1 whole square, and what we have gotten for this is m square minus 1, and this equals to limit h tends to 0 m square plus 1 minus 2m minus m square plus 1, and m square got cancelled, and this equals to limit h tends to 0 2 minus 2m. This is equals to 2 minus 2m, since this is independent of h. Again we are going to find out the right hand limit at x equals to m. So right hand limit at x equals to m, at x equals to m. So this can be, this is denoted as x tends to m plus, and this can be written as fx, and this equals to limit x tends to m plus bracket under x square minus x square bracket. Again this is can be written as limit h tends to 0, this is m plus h whole square minus this is m plus h whole square. Again this can be, how can we find out the value of this limit, right hand limit? So we know that m plus h lies in the right of the m but less than m plus 1. So definition, by definition of great engineer function, this becomes m. So this is m plus, again m plus h whole square equals to m square plus h square plus 2mh. Since h tends to 0, h is very smaller, so this can be equals to, this equals to m square plus 2mh. So this lies between the m square and less than m square plus 1. So value of this m square plus 2mh bracket equals to m square. So we have explained that, we have find that the we have found that this equals to, this is equal to limit h tends to 0, and this equals to m square, and this is m square minus m square equals to 0. Since so right hand limit at x equals to m is 0, and left hand limit at x equals to m is 2 minus 2m. So if the value and the functional value at x equals to m is 0, if the function is continuous, if the function is continuous at m, if the function is continuous, if the function is continuous at x equals to m, then limit at x tends to m fx must be equals to fm. And what is this? So we have gotten that, and limit x tends to m plus fx must be equals to limit x tends to m minus fx. What is this? Left hand limit f minus fx, and this is equals to fx. And what becomes this? This is equals to 0, and this is 2m, 2 minus 2m, and this is also 0. So 2m minus 2 equals to 0, so m equals to 1. So the function is continuous at only one integer, which is equals to 1. So the function fx equals to bracket of x square minus x square under bracket is continuous at continuous only at one integer, that is 1. So the function is discontinuous except 1. So the function is discontinuous at all integers except 1. So our the D choice is the correct choice for the given problem. We have 4 choice A, B, C, D. All in we have the option is all integer is the function is discontinuous at all integer except 1 is the answer. So this is the answer. So thus we have explained this.